An alien walked into a shop and told the owner that he came from Mars and wanted to buy a brain for research. "How much is this one?" he asked. "Well, that one is a monkey brain and it's $20, he explained. "How much is that one?" he asked. "Well, that one is a female brain and it's $100, he explained. "And how much is that one?" he asked. "That one is a male's brain and it is $500, he explained. "Why so expensive?" the alien asked. "Well, it has hardly been used."
Today we are talking about the HPA axis, or the hypothalamic pituitary adrenal axis, which is a complex set of direct influences and feedback interactions among three endocrine glands: the hypothalamus, the pituitary gland, which is a P-shaped structure located below the hypothalamus, and the adrenal gland, which is a small conical organ on top of the kidneys. These are important players in the endocrine system. The main purpose of the HPA axis is to react to stress, but it also controls other bodily functions such as digestion, the immune system, emotions, and many other things.
There are a couple key elements of the HPA axis. There is a paraventricular nucleus in the hypothalamus, which contains special neurons that synthesize CRH, or corticotropin-releasing hormones, which contain special neurons that synthesize CRH. These hormones act on the pituitary gland. This stimulates the secretion of ACTH, or corticotropin. ACTH acts on the adrenal cortex, which produces glucocorticoid hormones, but mainly cortisol in humans. This secreted hormones act back on the hypothalamus and pituitary to suppress the CRH and ACTH production in the negative feedback cycle that Becca was just telling you about.
I have another joke.
Not another one.
Okay. Let me just tell you why this whole negative feedback system is important in humans. The negative feedback loops keep hormone levels within the proper target range. When hormone levels begin to get too high, negative feedback allows them to lower. When ACTH is transported by the blood to the adrenal cortex of the adrenal glands, it rapidly stimulates biosynthesis of corticosteroids, such as cortisol from cholesterol. Cortisol is a major stress hormone and has effects on many tissues in the body, including the brain. In healthy individuals, cortisol rises rapidly after awakening, reaching a peak within 30 to 45 minutes. It then gradually falls over the day, rising again in late afternoon. Cortisol levels then fall in late evening, reaching a trough during the middle of the night. An abnormally flattened circadian cortisol cycle has been linked with chronic fatigue syndrome, insomnia, and burnout. Increased production of cortisol mediates alarm reactions to stress, facilitating an adaptive phase of a general adaptation syndrome in which alarm reactions, including the immune response, are suppressed, allowing the body to attempt countermeasures. The proper negative feedback cycle alleviates the harmful effects of stress to the hypothalamus and anterior pituitary by decreasing the concentration of ACTH and cortisol in the blood once the state of stress diminishes.
The HPA axis is involved in neurobiology of mood disorders and functional illnesses, including anxiety disorder, bipolar disorder, ADHD, and alcoholism. Antidepressants serve to regulate HPA axis function and are usually prescribed for many of these illnesses. They work by upregulating both the mineralocorticoid and glucocorticoid receptor, which are the two receptors that control the HPA axis. The MR regulates normal HPA function and GR regulates in times of stress.
This chart shows an example of HPA dysfunction. The solid lines show regular HPA function, while the dashed lines and the box on the left show what happens when the negative feedback loop is eliminated. Many things can cause this disruption. For example, social stress and physical stress have the same effects on the HPA axis, although they are stimulated through different pathways. If either of these pathways are affected, the HPA axis will malfunction. The treatment to HPA dysfunction also varies based on the cause. They're broken into 4 categories of lifestyle interventions, psychological treatments, nutritional treatments, and medical treatments. Studies on humans show that the HPA axis is activated in different ways during chronic stress depending on the type of stressor, the person's response to the stressor, and other factors. Stressors that are uncontrollable, threaten physical integrity, or involve trauma tend to have a high, flat profile of cortisol release, with lower than normal levels of cortisol in the morning and higher than normal levels in the evening, resulting in a high overall level of daily cortisol release. On the other hand, controllable stressors tend to produce higher than normal morning cortisol. Stress hormone release tends to decline gradually after a stressor occurs.